Good evening, ladies and gentlemen. Welcome back to the Burkowski household. Of course, I'd like to thank my wife for doing the filming. So what we're going to talk about today is power transmission. And there are three phases of power transmission for the most part, or how power gets to your house. So you have the power plant itself. You have within the power plant generators, which is taking some kind of motion and creating power. And then you have transformers, there are two types. There are step-up transformers, which leave the power plant and step up the power going through the transmission lines. And then you have step-down transformers, which are basically going into the local businesses or your household. So before I talk about each of them, I'm going to give you a general drawing. My wife is actually kind enough to actually do this drawing. So here you have a power plant, and it could be a coal-burning power plant, or it could be oil, or natural gas, or hydroelectric, or nuclear. All of them are designed to basically turn turbines, which spin generators, which then create power. That power is made somewhere about 200 to 300 volts per generator in a power plant. Then what you now have is called a step-up transformer. So it steps up the power, and we'll talk about transformers a little bit later. It steps up the power up to about 500,000 volts or 500 kilovolts, and sends that power over long distances, which again, we talked about is possible with AC power, but not with DC. Okay, so then as you reach the neighborhoods or businesses, it goes to a step-down transformer, and then it goes into the homes or businesses somewhere between 120 to 240 volts. And I told you 110, but actually the power outlets in your house can actually handle up to about 120 volts. So here's basically, again, a general flow of how it gets from the power plant through the transmission lines and into your home, okay? Now, so power plants. There are several different power plants, as I had discussed. All of them are designed to do the same thing, which is generate power for obvious, that's why they're called power plants. So basically, what you have is you have a turbine, which is generally some kind of propeller-looking device or something that actually spins. And then that's connected to the arm of the generator. And the generator is basically a magnet with a coil of wire. And that magnet spins inside that coil of wire, creating power. Now, as we talked about, you need really AC generators work the best for power over long distances. So if you basically create steam by boiling water, by using coal or oil or natural gas, or using plutonium rods to heat up the water, you are then spinning the turbine, which then connects to the generator, which then creates power. If you are using a hydroelectric power plant, the water itself spins the turbine, which connects to the generator, like the Hoover Dam. So those are power plants. And so really all of them do the same thing. They are just a building that is designed to create power by using different methods to get a turbine to spin, which connects to a generator. Now, so generators. This, ladies and gentlemen, is a very crude generator. This little, for lack of better words, this is your turbine on the end, and I am going to be the power plant. I'm going to be spinning this. It's connected by gears to this little metal box or cylinder. The cylinder has a magnet and a coil of wire inside it. It's a little generator, okay? So then my power would come out along these lines. So what I'm going to do is I'm going to take an ordinary little light bulb and I'm going to connect the leads. We don't want to insulate it away, okay? And all I got to do is now spin my turbine to get the generator to move, get the magnet inside to spin inside the wire. And we're not connected properly somehow. So let me figure this out. There we go. Okay. And I can spin in both directions. So this is a generator. I am creating motion. Sorry, let me say that again. This is a generator. I am spinning the turbine to create motion, which then creates power. Remember, a motor is the exact opposite. A motor takes power. Remember the battery we had and we spun the coil on top? A motor takes power and turns it into motion. A generator takes motion and turns it into power. Now, I'm going to show you something real quickly. If I take two generators and connect them, you can see that you can generate power in both directions. I'm not going to make it too quick, so here we go. You can see I can go this way or I can go the opposite direction. Okay, and so you can create, it doesn't really matter as long as you're creating a flow of current. All right, so that is generators. The last thing I would like to talk about are transformers. Transformers are a very important process in all of this because you need the power to be able to travel over long distances from the power plant itself. Remember I told you, no, I actually don't think I have told you, there are 4 actually power plants in Southern California, and I'll mention those in just a little bit, because I'll tell you what, instead of me talking about transformers, let's go outside and I can actually show you. So I'll show you a step-down transformer and I'll explain it kind of there, all right? So let's go. All right, so guys, what I was showing you before we came out here was about generators and power plants, transformers. So there are 3 or 4 major power plants in Southern California. If I remember correctly, there's Clearwater, there's Glenarm, there's Diablo Canyon, and there's San Onofre power plants from different varieties. Some are nuclear, some are coal burning, whatever. But they're power plants. Without AC transmission, you would need to have 1 power plant every mile, everywhere you go. So by having this AC transmission and these big power plants, you can generate power for large areas. So only 4 for Southern California, for all the population of Southern California. Now, I also mentioned to you transformers. Now, if my wife pans up to the top of the pole, you will see these 3 kind of tubes, and those are transformers. Okay, what a transformer does is it takes the power which is moving through these power lines at thousands of volts, and these are step-down transformers. So there is magnetic wire in these tubes that is coiled around, and as you go through this 3-stage transformer, it lowers the power each one, so when it enters the businesses or the homes, it's down to a standard 120, some 110, excuse me. Some businesses use as high as about maybe 220, but nothing compared to the power that's running through the lines. Coming from the power plants that I mentioned earlier, there are step-up transformers, and they use these coils, and as you go through these different tubes, the magnetic wire increases or decreases to either step up or step down the power, and so it can either leave the power plant to go to these neighborhoods and then stepping down to go back into it, and those are transformers. Okay, let's head back to the house. All right, so ladies and gentlemen, we are back. I hope now you have a better understanding of power transmission. I did talk about power plants, and there are several types really, but the main goal is to get a turbine to spin that connects to a generator that sends then power down power lines, and then, you know, eventually to your home. The generator is a device within the power plant that actually creates the power by using some type of motion, something that's getting that turbine to spin. The transformer, it then basically steps up the power so it can move along these power lines, and then steps it down so it can be useful in your homes. You can't have 500,000 volts coming out of your plug, or you would be, it wouldn't be good. It would not be pleasant anyway. So transformers, more than meets the eye with these things. Pretty awesome devices that actually all of this working together for power transmission. And Tesla's the one who kind of gave us the idea for all of this. So props to him again. So you all have a wonderful evening, and I guess I will see you next week. Thank you. Bye-bye.